Welcome back to Tech Talks from Commercial Baking. I'm your host, Maddie Lambert. In this episode, sponsored by FME, Food Machinery Engineering, I'm speaking with VP Daryl Verschere Glover about innovative new tooling options for cookie depositors. Daryl, thank you so much for being here with me today.
Thank you for having me.
So I want to start at the beginning here because wire cutters have been around for decades, and of course they work just fine with simple doughs, but modern eating preferences are pushing for more inclusion in their dough. So like chocolate chunks or fruit or nuts, and it makes getting a clean cut a little bit harder. So how does FME address this challenge with the induction heated knife?
Wire cutters have been around for, like you say, decades, but in reality, they've actually been in operation for, from what I've seen, even over a century at this point. And a wire does function as intended for the most part, but a wire under tension works until it meets something like an inclusion, like a chocolate chunk or a nut, something that wasn't necessarily designed to do. With inclusions, wires can deflect, snap, or smear dough across the die. All of this directly relates to inaccurate placement on a pan, wasted product in your oven. So raisins can actually wrap around the wire itself and just stay on the wire and keep cycling back and forth. So your surface area, which was the entire goal of the wire in the first place, was to reduce the surface area in which the dough can hold on to. So you do get a good release. But now with different type of cookies out there nowadays, we're running into this issue where we're getting inaccurate placement. The wires are acting more of a trampoline, and they just right now, from my point of view, is they aren't really cutting it, for lack of a better term. Our induction heated blade avoids all of that. It's rigid. It doesn't have a failure mechanism where it can snap or break and create downtime in the line. So it doesn't deflect, and the controlled heat reduces sticking. What that directly relates to is more accurate placement. You're cutting directly through inclusions, whether it's nuts, chocolates, or raisins, or any of the other kind of weird items that customers are really demanding these days. Yeah, it slices cleanly, the dough releases immediately, and you get a consistent cut no matter what's in the recipe.
So I want to pause really quick. How, when you say heated, how is it, like hot? Is it just warm? Like what kind of heat are we talking?
It's recipe dependent, really. I mean, realistically, you don't want it hot enough to melt chocolate per se. You don't want to give the cookie surface or face like an odd texture or anything like that. What you're really trying to accomplish is just getting to the melting point of the fats that are in the cookie. Realistically, after the first slice with like a heated knife, you'll basically build up a very thin layer of fat that's on that knife. And that's creating like the release. You don't necessarily want to introduce more of that product to the cookie, right? So this option, the induction coil itself, it's a non-contact surface. It doesn't actually heat up the dough itself either. Like if it does happen to be dough on the knife itself, it only interacts with the internal metal structure of the knife. So our knife in particular is a stainless steel substrate that's been coated with Teflon and cured that way. It's always difficult, even when you have like a heating element on a knife, for example. The induction coil in this particular case is where the knife comes back to its home position. The coil is wrapped around the very edge of the knife where you want to attack it. You don't want to move it back here where it's mounted to a bar or anything. You want it right at the edge where it's going to be doing the cutting. So it's a very particular placement and like actionable focus of heat in the knife.
It just sounds like it's such an intricate process, and what an amazing like way to streamline just cutting dough.
There's so many variables with every single dough recipe that, as much as I would love to create or know of like a universal machine that can handle absolutely every product that you could ever want under the sun, it's difficult to accomplish that. Our goal with this particular new tool is to reduce the limitations of customers, especially like co-manufacturers specifically, because they can grab work from all over their state or neighboring states, and not everyone has the same appeal to products that they're looking to manufacture. It kind of gives them a bit of a leg up in that sense.
That's a really good point. And as you know, the baking industry right now is seeing a push for mini cookies and smaller portion sizes as we continue to be in this better for you mindful indulgence era. So how does this push impact production on the floor?
Well, with mini cookies, your mixer is not going to change size. Your throughput of dough weight is ideally not going to change size. You're still pushing through the same amount of weight in dough through your machines. But the problem is that you're cutting far more cookies at far less weight. So a pan that would typically maybe have, say, 20 portions of dough on it, in terms of like mini cookies, for the same weight, you might need to have 50 to 60 cookies per pan, right? And with mini cookies specifically, especially the ones with inclusions, they're very difficult to place, especially with a wire or even like just a non-heated Teflon knife or non-stick surface, because the inertia of that cookie, like the weight of that cookie is so little now that the force enacted on it from the wire or knife or anything is that much greater. Like it has that much more of a chance to fling that cookie all over the pan. And so with the heated knife, you can actually maintain the high cut rate speed, because other options, you may not be able to cycle your knife as fast as you typically would. But in mini cookies, you need a faster cycle rate to maintain that throughput with the dough that you're consuming. With the heated knife, you can actually maintain a very high rate of speed and still maintain an accurate placement, even with those small cookies, specifically because you have a knife that's cutting through the cookies themselves. What we've actually realized as well is like cookies that have been cut with a wire versus a knife, the consumer appeal to the one that's been cut with a knife is actually more appealing to a customer, because you're not actually pushing inclusions into the cookie or out of the cookie or out of the cookie in some cases. You're actually like sectioning the cookies. You want to show off all those ingredients in the cookie, like they're there. So from a consumer's point of view, and I'm this way as well, if I see two cookies on a plate and one is showing like all of the inclusions because you've cut right through them and created like a new plane right through the cookie, as opposed to some like, oh, you see a little poke out here or a poke out there. I'm going for the one that's like absolutely loaded with chocolate and walnuts, right? I mean, that's just me.
Absolutely. I'm reaching for the cookie where I can see it's covered in chocolate chips. I don't want to have to dig for them. And to your point, when it comes to pan placement and oven efficiency with mini cookies, accuracy is critical. And because they're smaller, bakers are cutting and depositing more pieces per minute. So, like you said, the need for speed and precision is just way higher. How does the controlled temperature of the blade help bakers achieve this accuracy? Can you tell me a little bit more about that?
It's paramount on mini cookies to actually focus on placement. And in some cases, you may have to slow down your machine if your cutter isn't cutting it, right? If you're not actually achieving the placement that you want, you may have to make adjustments to speeds and throughput, which hurts you very quickly in the mini cookie world, you know?
Yeah, that disrupts production, which I mean can be detrimental for time.
You also want to make sure your oven is at its full capacity. You want to utilize the entire pan. You don't want to have too much space between your cookies. I mean, you do need space between cookies so they bake off evenly, right? We all know that, but you want to maximize pan utilization so you can maximize your oven utilization, especially in pan rack ovens, right?
Mhm. Okay, so we talked about the benefits of this solution. Operators don't have to slow down the machine or fix the placement by hand. And we talked about the beginning of wire cutters, but let's switch gears to talk about the future. So, how do you see this solution, this induction heated knife, redefining the standards of wire cutting and cookie depositing?
I think, wires solved the problem for a long time, but they were designed for doughs. And I mean, some cookie doughs haven't changed in years, but speeds of the equipment themselves have changed drastically. Like we have servos now. We are moving into a different era where servo motors are available to us. They run a lot faster than a pneumatic cylinder could. You can change gear ratios on everything on an AC motor, no issue, but there's a lot of control that you lose with those systems. So I think as recipes include sort of more inclusions and as lines demand higher throughput, those same wires become a limiting factor. And a heated blade removes those limits. And if we want to produce more with less, I think we'll look back on wire cutting as the first step of moving towards something best, right? But I don't think the wire cutting is the end point. I think that the heated blades will become the expected standard for clean, high speed cutting in the future. I may be biased towards it, but the results that I've seen in our testing and some of our customers utilizing this technology has been phenomenal, especially for sticky doughs that even on the wire with very little surface tension to hold on to that puck, we're able to place a lot faster, a lot quicker, far more accurate placement. And inclusions seem to be a non-issue for us, right? Even the raisins and cranberries, they don't hang up on a knife, they get cut and sliced through, right? So I think it's leaning more towards just the inevitable future. Like everyone loved bread and then it got sliced. And I think that's where we're heading with cookies as well, right?
I love that. I don't think inclusions are going anywhere. So this is kind of redefining and resetting the standard for how bakers can operate. So just one last question for you. what is the best way for bakers to get in touch with FME to learn more about this hot solution, pun intended?
It's a lot of puns here. The best step is to reach out to us at the FME Food Machinery Engineering.com or send us an email at info@FME Food Machinery Engineering. The most useful first step in a discussion is a technical one. So we would lay out and explore what you're trying to produce and manufacture, and that includes, your dough type, your inclusion size, the line speed, your pan layout, alternate products in your line, whether it's brownies or biscotti scones or cookies or mini cookies, etc. Once we understand those parameters, we can then show you how the knife integrates into that process. I mean, the easiest way to begin is to connect with our engineering group at FME through our website or email, and from there we can line up trials and work out the details on what next steps may look like.
Perfect. Well, Daryl, thank you so much for your time today. It was a lot of fun talking about the history and the future of wire cutting and what bakers are able to do and what they may be able to do in the future. So thank you so much for your time and your insights.
Yeah, thank you so much for having me.